Hi everyone, in this video I'm going to explain the stacks concept in data structures. So stack is a linear data structure which the data can be organized at one end. Means that is we can insert or delete any elements into a stack at one end which is said to be a top of the stack. So we'll start with the definition of a stack and then we'll see what are the different operations we are performing with stack and how we can perform and how to implement the stack operations with an example. So we'll start with the definition. So simply a stack is an ordered collection of homogeneous. So what do you mean by homogeneous means? Uh, Homogeneous is refers to as a similar data. So like you want to create a stack, then we want to insert a similar data. Like you can insert either integers or you can insert either floating point values or you can insert all of a character type. Means homogeneous is nothing but a similar data elements where the insertion and deletion operations occurs at only one end. And this end is often known as the top of the stack, right? So in stack, so we can perform all your deletions and insertion operations at the similar end, means the same end, which is said to be a top of the stack. So here the last element is inserted will be on the top of the stack, because suppose you can take simply this is your stack, right? So now your top of the stack position will be here. So this is your bottom of stack, right? Because your stack is empty now. So whatever the element you are going to insert it here, now your stack it will be placed here. So now the element is placed in this position, and after that you want to try to insert the another element, then your stack position it get increment and it will take the value and placed in this position. So what is the meaning of that? The last element which is to be inserted, that is available at the top of the stack position. Since the deletion is done from the same end, the last element inserted will be the first element is to be the removed from the stack. So see here I am inserted A first and then later B. Suppose if I am trying to delete an element from this stack, I can delete B first, right? So what your stack will say, so the last element which you inserted and that is the element which you to be removed first. Because of this your stack is also known as a last in first out. So whatever the element that can be inserted last, that will be deleted first. So it will follows the LIFO, means last in first out. Okay, and initially when stack is created using arrays, so array is of also a linear data type, the size of an array is fixed. So once you want to implement your stack with an arrays concept, then the size of the stack is fixed. So the stack base remains the fixed, while the stack top changes, the elements are inserted or deleted. So stack is same. Suppose if you want to insert your stack by array, means you want to take vertically. So suppose your array size is 5, right? So your array size is 5. So then what is the meaning of that? Your stack size is also 5 and it is capability to store maximum of 5 elements. I already said stack is a homogeneous data, so it can save the similar information. Okay, so once you fix the size of the stack, it remains fixed. Okay, what are the elements you want to inserted or deleted? So what happening every time the top of the stack position it will be changed, because we want to do any operation, so which your pointer can point by your top of the stack position. So most frequently accessible element in a stack is in the top and the last accessible element is in the bottom. Okay. So now I'll show you how your before you are going to take an insertion operation. So we'll see uh, what are the stack operations. Okay, so now I'll explain each and every stack operation here. So now what are the stack operations? A stack is generally implemented with two operations. The two basic operations are called like push and pop operations. Simply we can call the two operations which are going to implement in your stack is called as a one is push operation and second one is a pop operation. So push operation is nothing but it allows adding an element at the top of the stack. I already said we can do any operation either insertion or deletion we can do at the top of the stack position only. So whatever the position we have at the top of the stack, so there we have to insert an element. It's said to be a push operation. And now coming to a pop operation which allows to remove an element from the top of the stack. So we can perform either insertion or deletion from the top of the stack only. So now what do you mean by a push operation? So the process of adding a new element to the top of the stack is called as a push operation. See, simply you can take this is your stack. Okay, this is your stack. So now the stack is empty. So initially your stack is empty. So where your top of stack position it will be? So top of stack position will be taken as a -1. So this -1 indicates that the stack is empty. So now you want to insert a new element into the stack, empty stack. So now your top of stack position it get increment by 1. So -1. So now you can add +1. So it becomes to 0th position. So which will gives you the starting index of your stack. So now what's happening? Here you have to insert a element. Suppose if I want to insert 1 here. So now my top of stack position will be at 0th position and I inserted my value 1 here. If I want to add one more element here, then what I need to do? I need to increment my top of stack position by 1. So it will take 0 plus 1. So 1 position. So here I am trying to insert my value. So like this you can continue. So this process of adding a new element to the top of the stack is said to be a push operation. So pushing an element in a stack, it invokes adding of elements at the top. Suppose after inserting an element, the maximum size is reached. Suppose here you can take the size of this um, stack is 5. So now it is capability to store 5 elements. Suppose see here 3, 4 and 5. So I inserted 5 elements in my stack and after that my stack is full. Suppose if I am trying to insert one more element in my stack. So what simply it says that my stack is overflow. Right? See, it is not possible to insert any new elements. This situation is called as a stack overflow condition. At this point, the stack top is present at the highest location of the stack. So simply we can say array index starts from 0 and it ends with n minus 1. So now my array size is 5. So 0 is my starting index and then 0, 1, 2, 3, 4. So this is my max index. Right, so when your top of the stack will reach us the maximum position of your stack, simply we are trying to insert one more element into the stack. The situation it leads to be a overflow. So whenever you want to performing a push operation, like you want to add a new element to your stack, you always check whether your stack is getting overflow or not. So at this point simply what we are checking, so top equals to max size minus 1, then stack is overflow. So when we say simply your stack is overflow, so simply we can say your top of the stack position it will reach us the maximum size minus 1. See here your maximum size is 5 and minus 1 is nothing but 4. Okay, now I'll show you how you are performing this push operation with simple example. So the push operation is also known as simply we can say it is insertion operation. So simply the push operation is said to be a insertion operation. So this is an empty stack. See here, and initially you are taken an empty stack and here the size of the stack is 5. So because you can observe here the size of the stack is 5. So because we have 5 places here. So now initially your top of stack is at position -1. So which indicates that your stack is empty. And now you are trying to insert an elements like this order, the A, B, C, D, E. So because your array size is your stack size is 5, you want to insert these 5 elements in this stack. So now the first element is A. Now I want to insert this element. What I need to do, I want to check my top of the stack position. So whenever you want to performing an insertion operation, first the top of stack position, it get incremented by 1. So I already said here the initial position is -1. Now you get increment. Incrementation is nothing but you have to add 1 to the previous position. So it will give you the index as 0. So now you can say simply this is index 0, this is 1, this is 2, this is 3 and this is 4. Okay. So now when you are inserting A, so your top of stack position, it will be at position 0. So now you can simply insert A here. And now I want to insert my second element B. So then simply what I need to do, I can increment my top of the stack position by 1. Now it will 0 plus 1 will get the 1 position. So there I need to insert my second element B. And again I want to insert my third element. Again I need to increment my top of stack position. Now we get the second position. There I need to insert my third element. Like this we can insert all your 5 elements here. Suppose if I'm trying to insert the one more element F to my stack, then what's happening? So whenever I'm trying to insert a new element to a stack, it will check the top of the stack position, whether it reaches the maximum size -1 or not. If it is reaches maximum size -1, that indicates that my stack is overflow. So here is a situation your stack is overflow because your stack is already filled. So now there is no possibility of inserting this new element. Simply we can say your stack is overflow, right? So your stack is overflow. So there is no possible to insert a new element here. So now this is a explanation of this particular diagram. See, initially the stack is empty and it has a pointer, that is TOP. It points bottom of the stack, that is top equals to -1. When the elements are inserted into a stack pointer, the TOP is incremented and it's point to the topmost element in a stack. Right, so this is simply like push operation or insertion operation in a stacks. Okay, so now we'll move with the next operation. So simply we can take the next operation as a pop operation. So simply pop operation is nothing but deletion operation, right? So simply pop operation is nothing but a deletion operation. So what do you mean by a pop? Suppose if I want to delete something from a stack, you need to verify whether something is there in your stack or not. See, suppose if my stack is like this. So initially my stack is empty. Right, so no elements is available in my stack. If I'm trying to delete any element from this top of stack, then what's happening? It is meaningless because I didn't have any elements in my stack. I'm trying to delete something from that. So now this situation is called as a underflow. So simply we can say this is an underflow situation. So remember, whenever you want to insert something into your stack, you have to check whether your stack is overflow or not. Whenever you want to delete something from your stack, you have to check whether your stack is underflow or not. See, simply going to take an explanation of this pop operation. So the process of deleting an element from the top of the stack is called as a pop operation. After every pop operation, the stack is decremented by 1. See, I already said at the beginning, suppose if you have an elements like this in your stack. So whenever the last element is here, your top of stack position is here only. So now you want to delete an element where it takes element to delete, it takes top of the stack position only. So now you can delete this element D. So then what's happening? So whenever you delete this element, so now your top of stack, it doesn't consisting D here because you already deleted. Then what's happening? In order to take the next element, your top of stack, it gets to decrement by 1. See here, the position is 3. Now you want to take the next position, this will be 2. So how you are getting this value? You have to simply decrement the value by 1. So remember that whenever you want to delete an element from the top of the stack, that operation is said to be a pop operation. So every pop operation, your stack pointer, it gets to decremented by 1. Finally, when all the elements are deleted, top of the stack, it points to your bottom of the stack. When it reaches the bottom of stack, now your top will gets to -1. So now this -1 indicates that your stack is empty. So whenever you want to delete the elements when this position, it indicates that your stack is underflow. Right? See, thus if there is no element on a stack and the pop operation is performed, then this will be result into a underflow condition. So when your top equals to -1, then stack is underflow. It is possible. Verify the item placed at the top of the stack without removing it. This operation is called as a peep operation. So thus determining the top element of the stack without removing it from the stack is called as a peep operation. So before you are getting deleted element from your top of stack, you have to check whether your stack is underflow or not. So by checking that process is said to be a peep operation. So I'll explain with so now I'll try to explain this pop operation with simple example. Okay, so see, this is a deletion operation which is also said to be a pop operation. So what your pop operation will say, whenever you want to delete some element from your stack, so you have to check whether your stack is empty or not. So this is the position of your stack after you are inserting 5 elements in your stack. Right? So now where your top of stack position, it will be at the position 4. See, because see here, now your stack index starts from 0, 1, 2, 3 and 4. So it will be at the maximum size -1 position. Now we want to delete an element from this stack. So after this deletion, your stack will be like this only, because you are already deleted element E. So now your stack top pointer will get decrement and it will take the next position. So after deletion of this element, your top of the stack will get this position and it will take this as top of stack and it will remove this element here. And in next step, it will remove B and next step, it will remove A. Okay, so after deleting of that, your top gets at the position -1. So in this situation, you are trying to delete any element from this stack and that simply said to be a what it is? Underflow. Right? So what do you mean by underflow? Underflow is nothing but when stack is empty, now you are trying to delete something from the stack. So that simply said to be simply we can say that is a pop operation of a stack. So now I'll explain the algorithms of this push and pop operations. See, this is an algorithm for push and pop operation. So what I said, push operation is nothing but we are trying to insert, right? So push operation is nothing but insert operation. So now we are trying to insert something into your stack. So that simply is said to be a push operation. So now you can follow this algorithm for inserting an element into your stack. So what is the first step will say? Now we have to check whether your top of stack is max -1. So max -1 means what? So this is your stack and we are trying to implement the stack with an arrays concept and the maximum size of this is 5. So now your array index starts from 0, 1, 2, 3 and 4. Okay. So now your top position is at max -1. That indicates that what? So now your stack is full because your top is at this position, means you already filled all these positions with some values. Right? So now whenever you want to insert an element into your stack, first we have to check whether your top of stack is max -1 or not. If it is max -1, simply we can say your stack is overflow and we can stop. We cannot insert anything into this stack because that is not possible. And you just read your data. Else, suppose if your top of stack is not your max minus 1. That's simply what we can do. So we can read your data. That is, suppose if you want to insert A into your stack. Now you can read this A and you can increment your stack, top of stack position by 1. So initially your top is at minus 1 position, that indicates your stack is empty. So now you are reading this element and you are inserted into here. Then what we need to do, we want to increment your top position by 1. See here, this step will say we have to increment top of the stack position by 1, and the top of stack is consisting your data. So what is your data here? A. So now what's happening? Your top of stack position will having this data A. Simply we can repeat the steps. Suppose if you want to insert one more element here, again we have to check your stack is full or not. If it is not full, then what we have to do, we can read the data and we can increment your top of stack position by 1, and then we can place this value into that top of stack position. We can repeat until no element is there to insert into your stack, or so your stack top pointer will reach as the maximum size of your stack. So there is two terminations of your push operation. Okay, so simply we can stop. And now coming to your pop operation. So simply pop operation is nothing but the deletion operation. So whenever you want to delete something from your stack, you have to check whether your stack is empty or not. So why it is empty or not, you need to check, because if stack is empty, there is no possibility of deleting some element from that. So now that is said to be, see, top equals to, mean it's minus 0. Minus 0 indicates a negative value. So negative value is nothing but minus 1. So when top is minus 1, that indicates that your stack is empty. So you can simply write stack under flow and stop the procedure, because there is no element. We didn't delete any element from that. Otherwise, what we have to do, see here, this is your stack elements. So now what simply it says, top of stack null. So simply we can remove this and we can simply say this is null. See, null means what? You are removing this element from that. Now your top of stack position, it get decrement. Okay, now it get decrement and it will take this position. Okay, see then what we are doing, top of stack will get decrement, top minus 1. And then we can repeat these two steps. Right, we can repeat these 3 steps. Every time you need to check whether your top of stack is minus 1 or not. If it is not minus 1, then simply we can remove the element from your top of stack, and then you have to decrement your top position by 1. So these are the algorithms for pushing and popping operations. I hope you all can understand.